Today we're going to look at fractional exponents, or rational, because rational and fractional are the same thing. So we've been looking at different roots, like the nth root of b. That could be written as b raised to the 1 over n. The denominator of the exponent tells you the root you're taking. Now, if the top is something other than 1, like this, your denominator of your exponent tells you the root you're taking, and the numerator, the top number of your exponent, tells you the power that you're raising it to. Now, whether you raise your b to that power before you take your root, or take your root and then raise it to that power, does not really make a difference. Depends upon the problem what you might want to do. A lot of times I'll try to take the root first so that I end up dealing with smaller numbers. So, once again, the denominator of the exponent tells you the root to take. The numerator of the exponent tells you the power to raise it to. So to write this as a radical, the denominator is 6, so it would be the 6th root of a. Here our denominator is 2 of the exponent, so we would have the 2nd root of m, or the square root of m. So now, this one here, once again, is the 6th. Oh, wow, these two are just duplicated answers. I have no idea why I did that, sorry. But we got to write these now as fractional exponents. So it's the 4th root, so it would be raised to the 1/4 power. Here we have a cube root, so it would be y raised to the 1/3 power. Now, we're going to look at simplifying these. This problem here is a negative exponent. Remember, a negative exponent puts it in the other part of the fraction, so it's going to be 1 over 49 to the 1/2. Now, that 1/2 power really means a square root, so it's 1 over the square root of 49, which is just 1/7. When we're looking at a problem like this, it means the 5th root of 32 squared. Now, you could square the 32 and then take your 5th root, or you could take the 5th root of 32 and then square that answer. I'm going to choose the second approach because I know the 5th root of 32 is just 2. I still have to do that squaring. And so by doing it this way, I'm dealing with numbers I can easily do in my head. Because if I had to do it the first way of 32 squared, I don't know what 32 squared is off the top of my head. So see if you can quickly work out these two and then finish watching the video. Negative exponent puts it down in the bottom and makes it a positive exponent. This 1/2 power means the square root of that 25 in the bottom, which would be 1 over 5. Here we'd have 16 to the 3/4, which is the 4th root of a 16 cubed. Now, whether you choose to cube your 16, then do your 4th root, or try to do your cubing afterwards, doesn't make a difference. I'm going to do the cubing afterwards because the 4th root of 16 is 2. Then all I have to do is cube that, and I just get 8. Here we have y to the power times y to the power, and that goes back to what we were doing earlier in the chapter, that you just have to add your exponents. The exponents have to be added together. They have the same denominator, so you can write it as one fraction, add the top, keep the bottom the same. We started out with fractional exponents. We could probably leave our answer as fractional exponents like this. I mean, technically it could be written as the 7th root of y to the 5th, but I would probably just leave it as y to the 5/7 because we started out with fractional exponents. Typically, if you start out with fractional exponents, leave your answer with fractional exponents. If you were to start out with roots, leave your final answer with roots. Here we have a negative exponent, so it's going to flip it into the bottom. Now, remember, a fractional exponent is really a root, so it's a 1 over, and then it's the cube root of an a squared. Remember, we don't like to leave roots in the bottom, so we're not going to want to leave fractional exponents in the bottom. So simplifying the roots here is just like what we were doing in the previous section. You have to multiply by a special form of 1, so that on the bottom you would get the cube root of a cubed, multiply the tops, and now you know that the cube root of a cubed on the bottom is just a, and we would get this. Now, we did not start out with radicals, so we don't want to leave our answer with radicals. We're going to want to leave it with a fractional exponent of just a to the 1/3. We know the top is a 1/3 power. If that's the root, is the 3 in the bottom, and the power you're raising it to, which isn't written, which is assumed to be 1, that's what's on top. So quickly try to do these two. Add your exponents, and that would be your answer. Here, negative exponent puts it in the bottom. That fractional exponent in the bottom is really a root, fourth root of a cubed, multiplied by a special form of 1, multiply the tops, multiply the bottoms. You have the fourth root of a to the fourth n on the bottom, which you know simplifies to just a normal a on the bottom. We started out with fractional exponents, so you want to leave your answer as a fractional exponent. Here, there's not a whole lot we can probably do because our roots are different. However, you might want to think about them as fractional exponents. You should remember that 16 is really 2 to the 4th. So now on top you have an exponent raised to an exponent. You should remember when you multiply, or exponent raised to an exponent, you multiply your exponents and you get 2/3. So now we have 2 to the power on top over 2 to the power on the bottom. Which one has more 2's? You should realize the top has a 1/3 more. Or you could just subtract your exponents, which is a 1/3, and you get this. Now, we did not start out with fractional exponents. We started out with roots. So you're going to want to leave your answer with roots. Over here, you might be thinking there's nothing we can do to simplify this because 4 is only a 2 squared, and this is an x to the 4th. Your 2 squared and your x to the 4th are both smaller powers than your index in front of 6. However, we can use fractional exponents to help us out. Now we have exponents raised to exponents. We can go ahead and multiply our exponents in. Exponent times exponent, we multiply those in. We get a 1/3 here. We get a 2/3 power on our x because you get 4 over 6, which reduces down to 2/3. Now you should realize that your denominators are 3, so that means it's going to be a cube root, and then it would be a 2 to the 1st and an x squared still inside of your root. Now you maybe didn't see how to simplify your root, leaving it as a root, so sometimes it's going to be helpful to switch it over to fractional exponents and work with it. Or like a couple of these earlier problems where we started out with fractional exponents, switched it back to roots so that we could go ahead and simplify. So you need to be comfortable working back and forth. So see if you can do each one of these. So here, our 4 on top is a 2 squared. Our fourth root is a 1/4 power. Exponent raised to an exponent on top. You multiply your exponents. You get 2 to the 1/2 on top. You would get 2 to the 1/2 on the bottom. Top and bottom are the same, so you know you get 1. Now, over here on this one, you could work it out with fractional exponents, thinking of 16 as 2 to the 4th, your cube root as a 1/3 power, and then you could apply that 1/3 power to each one, and you would get this. Now, notice your exponent on your 2 is larger than 1, so you could write that 2 as 2 to the 1st plus a 1/3. That 2 to the 1st is a 2. Then you'd have a 2 to the 1/3, because remember, if you have an exponent or 2 to the power times 2 to the power, you add your exponents. So now you'd have a 2 in front of your root, and then here, this would really be inside of a cube root with a 2 to the 1st and an x squared. It could be done with fractional exponents, but you may wanted to have thought this problem as just a 2 to the 4th here, x squared, just like we did a couple sections ago, and then you would have went a 2 cubed with another 2, cube root of a 2 cubed, pulled that 2 out in front, 2 to the 1st and x squared are smaller than your index of 3 in front, can't simplify it and leave it like that. It could have been done either way. Once again, here we started out with root, so we want to leave our answer with root.